I don't know, it might be interesting to look at this one together. Let omega be the incircle of scalene triangle ABC. What? So ABC. Okay, that's not really scalene, but whatever. Omega. Omega be tangent to ABAC at x and y. Construct x prime, y prime on line segments AB and AC such that AX prime equals XB. AX prime. Oh, okay. So maybe it's like that is equal to that. Did you do a diagram? Which side is it on?
The excircle touch point. Michael,
And which one's longer? Oh yeah, it's the excircle touch point. Yes. Okay. So it looks like this then. It looks like that. Like, you know what I'm saying? Did you both get this? So you could communicate in the. He spoilt it. Well. Alright, okay. My bad.
You get annoyed at me for not telling him, and you get annoyed at me for telling him.
No, I was saying you probably told him at the start where there was no talking. And then, alright, I will step back and shoot it in your face.
And get blocked.
Wait, but I stepped back.
You'll still get blocked, so just that short.
Okay. So far the problem is understandable, yeah? X equals AY. I see. Let CX prime intersect omega at P and Q. Let CX prime intersect omega at P and Q. CX prime. Okay. P and Q. And let R be the intersection of the lines R be the intersection of the lines CX prime BY prime. So why did we do P and Q? Oh.
CP equals I.
Prove that CP equals RX prime. CP, let me do this in red. CP equals RX prime. Huh. How about that?
Pretty sure we also know PX is diameter of the incircle.
Diameter of the inner circle. PX.
Yeah.
Really?
So yeah.
How do you know this?
So
that is crazy. Oh, so you think you could Bary bash this? Is that what you said? It does reminisce of the Bary.
Oh yes, that's the only bad. The question, well, how in the world do you do this synthetically? Because this doesn't seem that crazy for Bary Bash. Like,
do you want to try Bary bash?
Why don't we first try synthetic? Because the Bary Bash, it seems doable. Because we know X.
Well, you have not. How many Bary bashes have you done in your life?
Not many.
This is we don't say seems doable. It's like basketball. It seems doable, but it's like the entire sport is an execution problem. You know what I'm saying? It's like throw it in the hoop. It seems doable. I don't think we have time for both right now, but we can try a little bit of both. Right? How do you know it's a diameter? What are these lines? So yeah, I guess Bary Bash it looks pretty good because I know the equations of the two lines, so we kind of know R, right? We know X prime, so we know Rx prime. Yeah. Oh, we just don't know P. What's P?
Oh yeah, I remember how to prove it.
Prove what?
Actually.
So we just don't have P.
I guess if it's the diameter.
Oh, so if you have a diameter, you think you get P?
I mean, we know that there's
You
a
think
tangent at P to the incircle that's parallel to the base.
there's a tangent at P? That's what?
Parallel to the base, and then that gives you that it's the because dilation, right? The excircle touch point, like P. If you dilate back, P like
Okay. So this is kind of like incircle,
yeah,
excircle, center.
yeah.
Like that, alright? And this is like the radius. This is a diameter.
Mm.
And this is like a diameter, yeah? Insane.
Yeah. Because we know that
Well, that's P.
yeah. Because we know that this dilates to this, right? If we take dilation backwards. So there's a tangent to the Michael, we know there's a tangent to the incircle at P that's parallel to this. Right?
Parallel to the base.
Yeah. This is a tangent, we know that's 90. We know that's 90. Those two are parallel, goes to the same point. It must be the same line.
Well, I thought we already knew it was a line because of dilation.
Oh yeah, that's true. But yeah.
Oh, so we know quite a lot about this.
But the problem is R. We know like beyond the bash standpoint, we don't know anything synthetic.
How do we describe P? P is...
Could you reflect it on X on the center?
Oh, wait, so what? Reflect what?
X on the inside. In the
Reflect X about the incenter to P. Like a midpoint thing. Oh. Hey. Yeah. Wait, how do you do midpoints in Bary Bash? Right, Lachlan had a good idea to get P. We somehow do like a midpoint thing with I and X with Bary. How do we do midpoint in Bary? Is it just the average of the points?
Sure.
Not sure, sure.
Not sure.
Hmm.
Not so sure. I said not sure.
I feel like it is a midpoint. I mean, is it mid? It's just like the average of the points.
Is it easy to find the intersection of things in Bary?
Well, it's easy to find equations of lines
Okay, then.
that goes through the vertices of the triangle.
Then R should be pretty simple.
Yeah.
Yeah, P you do a midpoint reflection.
Hmm.
Oh, so can I have
We
the
search
Nutella?
it up.
Can I have
Huh?
Nutella on bread, so.
Oh, we don't need to search. Oh, we're mathematicians.
Sir,
Huh?
I
What?
have Nutella on bread.
That's one
Already?
I'm hungry, sir. I never get to eat that at home. It's always like bread with avocado or something like that.
How much is
Avocado?
this? Is mine?
Oh, I guess so. An avocado, whilst healthy, does not taste as good as Nutella.
Yeah, I know they give you a lot of freedom. They come with good responsibilities. But it's like, let's get that comment over with. So we can move on to more pressing and important matters.
Like solving the
my
problem.
Nutella.
No, sir. Solving the problem, that's the pressing matter. Like, is it not?
I think Bary's perfect with the time we have right now till break.
Yeah. I think Bary's problem, so.
So flippant.
No, I think Bary is promising. I always thought that. I'm just more curious as to how to do it synthetically.
But you should be curious about how to execute the Bary.
I am as well. Curious about both doesn't mean I'm equally curious.
Alright. You know what would make this worse? If you said it with Nutella all over your face, okay? That would make that a little bit worse.
Nutella all over you.
He doesn't understand this guy. Alright, come on. Let's do it. It's a review as well. Because what are you going to do? Like, okay, I don't like saying what are you going to do in the exam, but like, if you're in the exam, as you would be in life, you don't necessarily want to look it up, you know? Like before I was 30, I never looked anything up. I felt it was like a challenge to figure everything out.
What happened when you said?
I realized, wait, maybe not 30, but like at some point in my 30s, I realized I had kids. Anyway, so
You realized you had kids.
yeah.
I don't know why.
Alright, wait, well, I was gonna say something about, oh yeah, also like, yeah, we can do this as a team, okay? And you can't say, oh, in the exam we can't do that as a team, okay? Screw that, okay? There'll be lots of situations in your life where you'll need to do stuff as a team. Like you might be out in a conference and then you have to solve this unsolved problem with your collaborators in like the one day that you have in the conference. You know what I'm saying? Yeah. Okay. Yeah, let's do it. How do we do it?
Work out the points.
Just find R first. That one's easy one.
Yeah, it's actually okay. We need to remember some things.
Is finding perpendiculars hard, Michael, in Bary?
I think so, but doable.
But then we can just find the perpendicular line at X.
Oh, you mean the equation of the line?
Yeah.
Yeah, but midpoint. Alright, there's some things we should be able to do anyway. Like, how do we get the Sevians? How do we get cx prime, by prime? How do we do these things? Yes, Bary can be used on AIMO, despite how overkill it can be sometimes.
Inversion can be used on AI.
Yeah. But when I say can be used, I'm just saying like you can use it to solve the problem. Not saying anyone will understand your solution.
Invert on AI mode,
Yeah.
which is probably going to happen this year by someone, not naming names. You know who I'm talking about.
Yeah.
Yeah.
Alright. Come on, let's do this. So I will start by labeling the points. Yes? I did the easy one. You gonna have a plate, or are you just gonna?
Oh! So I didn't spill any. You're not worried.
You got a plate, left it on the table, and just ate it over the couch.
I'm a professional eater.
If it were up to you, you'd probably eat it over the hole in the cover, just to annoy me. It's not cool to annoy me. I have a somewhat decent memory, so I remember, and I will hate you a little bit more every time. Let's get that over with. Move on to the next thing. Alright, what's the equation of cx prime? How about that?
I mean, just find CX and then reflect it, right?
Find cx and reflect it. What? Are we doing the same thing here?
Because we're trying to find CX prime, right?
Yeah.
You can find the equation of line 6 and just reflect it over me.
What? Why don't we just find it directly?
That's
X and x prime aren't that different.
true, that's true. That's a good argument. Very wise, sir.
Alright, so what's x? Do you know? How do we find coordinates of x and x prime?
I'm not sure.
I'm not sure.
Not very sure.
Okay, so usually we label the sides of the triangle like A,
B.
B, and C, right?
Mm-hmm.
Like, do you remember what length that is here?
Oh, that's equal, yeah.
What's that length?
AX prime.
Okay.
But it's also
What is it?
touch point to B.
We actually know the value of the length.
Yeah.
Yeah, and that will help to find the coordinates.
What is the value of
You don't know the value?
Oh, fucking bottom.
This is some junior to intermediate crap right here.
What is the value, sir?
Maybe you need to teach this in junior class.
I'll teach this to Judy. What's the value?
See how easy he makes promises? Because he knows he doesn't have to keep them.
So, I want to know what the value is.
Other people, they're like, oh, can I make this promise?
So I want to
What
know
does it mean to
I
make
want
this
to move on to
promise?
the important thing, like finding out what the value is.
He has many opinions, this guy.
Mm-hmm.
You're at my mercy because you don't know the value. That's your problem. Is it like S minus C or S minus something? It's S minus...
Oh.
You remember what it was?
B. S minus B.
S minus B?
Yep.
Then that's S minus B as well.
Yep.
This is S minus C. S minus C?
No. S minus A. S minus A.
What?
What?
That don't make no sense to me.
It's probably S minus A.
It is S minus A. Because this thing, it reflects over to this, so the length C has that component in it. the length A has both of the other components of the semi-perimeter that aren't.
And also, otherwise, to think that A would be S minus A. Would be very simple.
Exactly.
Uh,
It's S minus A. Because you're looking at, like, which part of the semi-perimeter doesn't include the reflected portion. Like, or which of the sides don't have that length in them, right?
okay. Because S minus A, right?
Yeah. And the last one is S minus.
Well, we don't need the last one. Thanks.
That's true. It's true, sir. That's true.
It's alright. Back to my Nutella.
Sir, I'm literally being contributing. You just complain.
He's being contributing. Alright. Okay, so what's the coordinates of x prime then?
Do
you know?
I know the last one's 0.
Ah. Wait. What? Which one's 0?
Isn't it the last one?
Oh, the C.
Two of them. Oh, one of them.
Yeah.
Would it be
Wouldn't it be like S minus B on C?
Okay, which one?
The first.
Mm.
Wait, I mean, wait. Wait. No.
What's the other one?
A minus S plus B. I mean, C minus S plus B and C.
You could also just put the other one as S minus A on C.
Really? C plus B minus S is S minus A, is that what you're saying?
Because, right?
Wait.
It's equivalent to this thing.
Is it just minus A?
Right? It's equivalent to this line, which is equal to semi-perimeter minus A. Or, what?
Okay, so this is B plus C on 2.
Yeah. C plus B minus
Minus A on 2. What's that? That's like a plus A on 2 minus A on 2. So you're saying it's S minus A, yeah? Okay, you're right. So it's S minus B on C, S minus A on C. Yeah? Oh, that's kind of nice. So if that's S minus A, what's this one then? It's S minus C, is it?
yeah.
Huh?
Yeah.
And this is what B is 0. So it's this is 0 in the middle, and S minus A on B, S minus C on B. All right.
Yeah.
Okay. Do you know how the equation of the Sevian works?
It's the same.
So like the equation of
line starting at the vertex.
this line, and this line.
Do the two things on the side stay constant, just the zero thing vary?
Yeah, so what basically happens is the zero thing varies.
Yeah, and the other two stay constant.
The ratio of the other two stays constant.
Yeah.
The other two has to vary as well if you want to keep it
Yeah.
normalized or whatever. But the ratio stays the same. Yeah. Yeah, so R is a point where the ratios. Yeah. Uh, hmm. Yeah, so R is a point where the ratio of the first and third is S minus C on B, S minus C on S minus A, and the second and first and second is S minus A on X minus B. You know? So R has coordinates. R is like X, Y, Z. X over Y equals S minus A over S minus B. And like X over Z equals S minus C over S minus A. You know?
Yeah.
So that should allow us to solve for these things.
I guess the first one's.
Huh?
First one is like S minus 8 and S minus 8.
What is it? S minus A times S minus C.
The second one, S minus B times S minus C. The last one is like S minus A times S minus C.
S minus C.
Wait,
Should be good.
I mean, oh wait, S minus 8 times S minus.
What's S minus?
The S minus A squared.
It should be S minus B. Like, really doesn't make any sense for it not to be.
X over Z is meant to be S minus C on S minus A. So there should be an S minus A
Yeah, S minus
squared.
A.
Sure. Because the, like, Y on Z should equal, like, something.
Yeah, Y on Z is like
Should be like whatever the equivalent.
S minus C, S minus B on S minus A squared.
It should, Michael.
Hmm?
It should also be like. Wait, what's X on Z again?
S minus C on S minus A. Yeah, I think it's S minus A squared.
Sure.
Let me just erase some stuff. S minus A, S minus C, S minus B, S minus C, S minus A squared. No, that's
The
R.
ratio for the Z, but I mean, but Z on X, Y or whatever, should be like something to things like S minus. It should be some form of S
Z
plus
on
B.
Y.
Yeah.
Okay.
Or Y on Z, whichever one it's
Are
meant to
they
be.
gonna like?
Because the like equivalent, the other in the third excenter touch point also passes through R.
Does it?
Pretty sure, yeah.
How do you know that?
Um,
So what's the third one? It's the ratio of y and z.
wait, Michael, just do the Severs theorem because we know all the lengths. The third excenter touch point, I'm pretty sure. Wait, Severs would be like cy on ya times ax on xb times blah blah blah, right?
Mm-hmm.
So then that's like s minus a on s minus c. Yeah, s minus a. Yeah, s minus a on s minus c times s minus b on s minus a.
Actually, he might be
Times
right. Wait, Sever's theorem says, because we know that the incenter ones. Oh wait, no, we don't know the incenter ones are concurrent. Yeah,
but it should be
equivalent.
I'm pretty sure you can do it very very easily using Severs because we know all the lengths, right?
Yeah, but do the lengths cancel?
Just wait, draw in the final lengths of the final incenter touch point. I mean excenter touch point. So,
Excenter touch point.
yeah, because we know if it holds for one, it holds for the other. Just draw in the final set of lengths. Just draw in the other excenter touch point.
S minus C.
Um,
Do we know which side it's on though?
yeah, because we know which side. It's on the opposite side as the ones for the. Yeah. Yeah, it should be S minus C and then S minus B, right?
S minus B.
Yeah.
Um.
Because we know what all the lengths are, right? Because and it's pretty clear that it'll cancel any separate. Because like S minus C, S minus B, S minus A, S minus B. Wait. S minus.
They have to be in the right order. How do we
Yeah.
know they're in the right order?
S minus C.
Because just check. It 100% should be concurrent when it's in the right order.
Really?
Right? Even you can be because you have like every single S minus something length appears twice, right? And they should all form in the correct manner.
S minus B, S minus A, S minus C on S minus B. Well, hmm.
I'm pretty sure I also read on something that they're concurrent as well. So in like there's some point I think it's like called the Nagel Point or something, or those lines intersect.
Okay, well.
Are we sure S minus A squared over S minus B times S minus C isn't like the right thing?
So he's saying that. So like if they're concurrent,
Yeah.
then the ratio of the x and the y, there's x and the
The one
y and the z should be also of this form.
Are we sure the ratio isn't right? Currently?
Michael,
Uh,
100% sure they intersect. You can
100%
basically
sure.
prove it by just drawing out the line. Only like
I feel like the ratio should work.
yeah, no, Michael. You know the
So what do we do wrong?
The incenter ones are like obviously concurrent, right? Because for the incenter ones, wherever the incenter touch point is, that length and that length are equal. That length and that length are equal, and that length and that length are equal. So it's,
Yes, you're right.
yeah, and it's obvious the other one has. You're just swapping all the ratios, so you know it maintains like the set.
What was the definition of isotomic conjugate?
It's a reflection of the medium.
Oh, okay, so it's not that.
No, you're talking about like
Anyway, so
there's two different ones. There's like isotomic and iso something. There's one that sounds very similar that means the median reflection. One means angle bisector reflection.
Isometric.
okay, so we want to draw a diagram.
Seems we've made a mistake somewhere. Which means we don't know where.
Okay, so maybe we want to check that if A is here and B is here, right? And we have a point that's like X, Y, yeah? And the coordinates is like X, Y, 0, yeah? Like with some normalization. Like if X is like 1 and Y is 2, right? It's closer to B, yeah? So B should be bigger. Like there should be more weight on B. So if it's twice as close to B, there should be twice as heavy at B. Yeah, I think that's right. That's the coordinates, yeah.
Yeah.
Oh, and are we sure AX prime is S minus B?
There's no reflection, right?
Huh?
No XB is S minus B.
怎么肚子又饿了呀？ 我给你吃好吗？
So if S minus B, what if it's over halfway? How does that work? Is it still? It doesn't matter if it's over halfway, does it? Like, is this what's happening? Like, we have A and B with X prime, yeah? And AX prime is S minus B, and X prime B is S minus A. Is that what's happening?
The last one is simply S minus A squared.
Huh?
Like it should be roughly symmetric, right? In terms of A, B, and C. Like the S minus A, S minus B, and S minus C terms. Should be at least somewhat kind of symmetrical cycle.
Okay. I mean, something's gone wrong. So if it's S minus B and S minus A like this, right? then the coordinates should be the reverse. So it should be x minus a, s minus b. You know? So maybe these are backwards. What happened here? So we have a and c, right? This is a and this is c. And then we have y prime. No? Where does y prime go? So is a y prime s minus a?
Yeah.
Are we sure of that?
Yeah, no, so
Wait, isn't a y prime s minus c?
Yeah.
So that's what's wrong.
Yeah.
So who said s minus a before?
but if that's true, should the other one be s minus a?
Alright, hold on. So the way I'm seeing it now is this length here, right? So I know for a fact this length is s, yeah. And so this is minus c. It's this length is subtracted to get this length, you know.
Isn't one of the right s minus a?
Yeah. So this is s minus c, right? Then this thing should be b plus c minus s. So it's s minus a. Yeah.
Wait, but are we sure ax prime? Wait, never mind. Oh wait, never mind.
Yeah, we made that mistake, and that explains why it's not the right way for the.
Okay, that's good. I mean, that's glad we sorted that out. And we learned something. They're concurrent, yes? So it's s minus a, s minus c on b. Yeah?
So x over z should be.
Yeah, so I think then it's kind of obvious what to do for r now, you know? It's actually easier, because it's more symmetric. So r should just be s minus a, s minus b, s minus c, right?
Yeah, that makes a lot of sense.
Divided by, like, s or something.
3点出去。诺索那边，你可以去那边买一个 caramel marker。明天他过生日。
不行，我晚点去吧。
晚点去可能就下班了，6点以后都下班了。
是 Coles 吗？
Coles 没有吧？
是在哪？
那种蛋糕店。
什么蛋糕店？
不是那种喝茶的、喝咖啡的地方。
在那个 shopping center。
其实我也不知道有没有。
Michael having to do stuff.
Really funny when the understand what's happening.
Yeah. What is happening?
So
有吗？要去做吗？
就是
谁的生日？
Oh.
明天。
And he's been told to go to the shopping center.
那个 shop 关了，
Wait, that's even more funny. How unbothered
那个
Michael
因为大蛋糕有很多蛋糕，但没有那个 caramel marker。
你说在 shopping center 看是吧？看我 market。哦。
你就花10分钟。
好，我做。
没有就算了，我再想办法。
好。
不行。
You look very disappointed in the fact your child is having a birthday.
It's not my child. It's my dad. Alright.
Translator is not translating very well.
My bad.
He said it was your even still.
Yeah, so it's like a S.
Yes, it's s.
Divided by S, yeah?
Yes.
That's pretty nice. And then,
So we need to find P.
okay, we know I. I think we know I, but maybe not as nice as.
What's I?
So I is like. It's the same. It's the same idea with the Sevians, right?
Is I the incenter?
Yeah. So I is You guys know I?
Like what it is.
Isn't the
Yeah.
incenter like A B C?
Yeah.
Oh.
How do you know that?
Well, that's actually
When? What?
like when I was doing it.
Oh.
See, I'm not the only bad student you have.
Does that make you feel better?
Yes.
It shouldn't.
I know.
You just want to make all my students bad.
No, it's just like you were like saying how good of a student Lachlan is, and it's like.
And then I put him in a room with you.
I was quiet. I wasn't saying.
Looking up your phone. Lachlan thinking it's okay to look up his phone. Not realizing he needed to play Geometry Dash. And getting worse at Geometry Dash the whole time. Yeah, it's ABC, right? Do you know why?
Is it like the same logic?
Yeah. What's the same logic though?
Everything's like reverse.
Bluffing.
Everything is reversed. Oh, it's just angle bisector theorem.
Yeah, angle bisector theorem.
Everything's reversed.
Alright, so you have angle bisector, right?
So it's A on C, like the ratio.
If you have the angle bisector, the ratio of this to that. So like if it's A, B, C, right? This is C, B. So the ratio is like
B, C, B.
B is to C, right?
Yeah.
And then you swap it because it's the coordinates are reversed. So it's B is to C. Does that make sense?
Yeah.
Huh? Does it make sense?
Yeah.
Alright. Because I is ABC, but it's over like 2S. You know what I mean? If you want to normalize it.
Now we just need to find the reflection.
Yeah. And we can check that the reflection lies on the equation. You know what I mean? Yeah. What are you even looking at? You don't even have your phone. Actually, it was funny because when you had your Nutella sandwich, it looked like you were using it like a smartphone. You're just like... Alright.
Ah, yes, my Nutella sandwich smartphone.
Okay, let's clear some space. So Charlotte, instead of coming to the Holo program, she just distracts you by texting you. Okay, anyway, so how to reflect? So we have x prime, no x, right? Not x prime. So x, what's the coordinates of x? X is like
X prime is off the route.
S minus B on C, yeah? That's x, yeah?
Yeah.
And we reflected the x
About A, B, C.
about I.
Yeah.
Yes?
Yeah.
To get P.
Yeah.
So P plus x on 2 should equal I, yeah?
Probably.
Yes?
Yeah.
Okay, I think the easiest one to do is...
The last one.
Oh, and if they add up to 1, obviously the coordinates add up to 1 as well, yeah? The normalized, I think that works for normal. If you don't normalize it, you can't do this midpoint thing, okay? You can't average the infinite sum things.
Yeah.
Okay, so P plus X on 2. So the Z value plus 0 on 2 equals
C on 2S.
C on 2S, yeah?
So it's 2C on 2, so it's just C on S.
He do it very fast. P equals. You're saying C on S? Is it?
Wait.
C on
C on 4S.
4S? What?
Maybe it's just
No,
maybe
C on S. C on S. He's right. I was high.
C on S. Okay. Okay, well that's one coordinate down. Is that the coordinate we can actually use? Okay, that's the coordinate we can't use to check anything, okay? It's the other two coordinates that we can use. Okay, so what's the other coordinate? So B on 2S is meant to equal y plus S minus A on C on 2. Yeah? Is that right?
Yes.
Okay, so y equals half B on S minus S minus A on C. So it's plus A minus S on C. Yeah? You guys should probably do this on paper or something, algebra people.
Wait,
You can't just stare.
Why isn't
That's
it
how I
beyond
solve
to
every
it?
problem I've ever solved.
And is that gonna be on your tombstone?
Yeah.
Your crowning achievement for your life?
Exactly, that's my thought process. So.
What I've done to get to this point is all I'm ever gonna do from this point on.
I'm
I mean, if you just say it, it sounds stupid, right? But you live by these principles, and it offends you somehow.
And you live in your chair and don't leave it. So you know.
How does this make sense? Ugh. Oh. Okay, B over S.
Wait, are you sure there's a half?
Sure.
Wait.
I am. You mean on this side here?
No, I don't know, around the thing.
Oh, I'm just taking out the common 2 here.
Yeah.
Oh, actually, wait, you're right. I should be timesing by 2, yeah? That's what you mean, yeah?
So you just do nothing.
Yeah, there's just nothing.
Yeah. Yeah, that's what I meant. What? What?
Okay, let me just write this down for now. You guys get some paper. See, the fundamental issue is you're just watching me do this. You need to actually do this. Like, would you put all your marbles on the line for this in, like, you know what I'm saying? Come on, like Kobe's like, oh, I practice like just as hard as I play, so in the game it's no different. Can you say the same?
Yes.
No, you can't. You're actually like this on the couch right now with no pen,
That's basically what
reacting to what I'm
The
doing.
last one is, but the last one is literally just swap it out.
Ooh, okay, so wait, so it's instead of
The A and the B are swapped.
A, you have a B. Oh, so you swap the A and the B, yeah? Okay, so you have A
Yeah.
makes sense plus B minus S on C. It's still on C.
Yeah.
Also, wait, so wait. Oh, I almost thought the X and Y values were the same for a sec, but they're not. Fractions don't work like that. Okay, so now the ultimate test is X over Y, S minus A over S minus B. And do this on a piece of paper.
Wait, how do you prove that it's
So we want to show it lies on CX prime, right?
C X? What lies on C?
P.
A mistake wasn't made right now.
Like,
Yeah.
oh.
You could have a whole piece of paper. There's some over here.
S minus A.
Wait, how do we prove this?
Just divide x by y and show it's s minus a on s minus b.
Hmm. Something. I don't know how to factorize it.
What?
Wait, sir, have you got it?
I got an idea. I'm trying to hard factorize s minus a out of the top. Does that make sense? So basically mod s minus a. Because you're kind of you want that. So it might be easier to do it knowing you'll get that. Oh, something does come out. Yeah, I got it, yeah. It's a very nice little problem, isn't it?
I'm stuck.
But okay. Once you got that, we can just go and we can do the distance thing when we get back. Hmm. You guys get no? Yeah, so these coordinates are right, I think. I'll just pause the recording. Mhm. Do you know what I mean by hard factorize?
No.
No, you just decided to hear what I said and ignore it.
I mean, doesn't like try and get it out or what?
No. It's a routine thing. It's not. It's not just try harder to factorize. Okay, I admit I did make the word up, but I've been using it quite a few times. You just seem to not care what it means.
I just always assumed it meant like you just try and hard factorize it out, you know?
So as opposed to just like chill factorize. It's not about the actual technique
just
or
when you're trying
result.
to
It's
force
about the
it out,
effort
you know?
you.
Like,
No, it's like this. Okay, let me just. So I'm sure you both got. Let's pick a. What's a striking color? Blue. Does that stand out? So you got this right. AC plus BS minus S squared
yeah.
on BC plus AS minus S squared, right? So this is kind of what I mean by hard factorize. So you take like the B you could like you want S minus A, right?
Yeah.
So you take the BS and you turn it into like BS minus A. You know what I mean?
Mm-hmm.
But you get back an AB. You know?
Yeah.
Oh.
Okay. So this is the same as mod S minus A, but you're keeping track of what's being multiplied. It's division, yeah? It's literally division. So, and then you have an AC, right, left over, and then the S squared, you could do like A squared minus S squared.
Yeah.
So you could do like A squared minus S squared, right?
Yeah.
But then you have to minus A squared to cancel the A squared you put in, right? Well then now look at this. Now you're factorizing this now, right?
Mm.
You see? You never did this, did you?
No.
Alright, and then this has a factor of A, right? You can see that.
Yeah.
And then it's B plus C minus A. You know? Do you know how to factorize that from there on?
It's like S minus 2A.
Yeah, so if you add an A here, right?
Yeah.
And it's minus 2A here, yeah? And this is 2S minus 2A.
Yeah.
So this is 2A outside of S minus A. Yeah? That makes sense? And so now the numerator is S minus A outside of B plus A minus S plus A, yeah? So B minus S minus A, right?
Yeah.
Plus 2A, yeah?
Mm.
And notice this thing here is symmetric in A and B, right?
Yeah.
So because it's symmetric, it'll be the same factorization with S minus B on the bottom, and they cancel.
Yeah.
That make sense?
Yeah.
Hard factorize. I'm just trying 80% harder to factorize.
I don't know what hard factorize would mean.
Yeah, I never think people have two modes. We're always trying our hardest, right?
Yeah.
So I can't anymore
I know.
because
It just
I'm
sounds like
old.
really when you're just trying to force it out in the factorization. You know what I'm saying?
Alright, okay, we'll resume the distance thing in maybe another recording.
Right.
But we know the coordinates of the points now.
Yeah.
Okay, the unmute thing doesn't make sense now. Okay, so basically we have the coordinates of 4 points. What's the distance formula? Do you remember? I should look it up.
Distance.
What's the distance? Have we ever proved the distance formula? Maybe we need to prove it at some point, but what do you do with distance formula? Let's think. So distance formula is like, yeah, it's kind of like treating the points as like vectors, you know, like 3, and then maybe you're doing like a dot product or something. Do I have distance formula here? If you look at the inter book, do we have distance formula? There should be a chapter on Bary. Yeah, there you go. Hey, making use of the shelf. Hey, that shelf just paid for itself.
Forward back. Wait.
Do you have a copy of that book?
Wait. Isn't there a chapter on? Oh wait, never mind. Complex dash. Barycentric coordinate. Page 190.
Oh, you found it faster than me. Oh. There's a little bit of a mistake in there, but hopefully you can pick it up. I said something kind of wrong.
Page 190. Distance.
You know what the funny thing is?
P.
If you were given your own book but you didn't write it, you'd be like, I don't know how much we should like trust this. We should be aware there are mistakes in it. Like you would though.
Oh, but I would like the book. It's got lots of proofs. It's
You would
very
like the
thorough.
book, but you
I'm
won't.
not. This is. when x plus y plus z equals 0, I don't know, pq squared equals minus a squared yz
Oh, so it is in here.
minus b squared xz minus c squared xy.
Yeah. Yeah, so when it's equal to 0, it's because you take the difference, right? So it equals 0. What page is it?
193.
There, you're on it right there, sir. Distance formula. Your cursor's literally on it.
Oh, that's 199 on this one. Oh, it's been updated since the print.
Oh my gosh.
Oh, okay. Well, it has no proof here, so we could prove it.
Maybe we use it first and then prove it.
Yeah, we can prove it later. So what's the distance formula? Yeah, so you take the difference and then you do minus a squared yz minus, yeah, so this is part of the equation of the circle thing. Minus b squared xz minus c squared xy. Yeah? And then the points that we have, remember what we want? We want CP, right?
Yeah.
P equals yeah. So, and then we have R x prime S, and x prime is just the same. Let's see, yeah? Alright, which one do you want to do? You need paper and pen for this. There's a clipboard under there.
RX. Alright.
You want to do RX or PC?
I'll do RX.
RX?
So I do PC.
Alright. Is there any more paper down there? Yeah, there should be lots. Possibly some. Okay, cool.
How do you just take the difference?
Yeah, so.
PQ is equal to XYZ.
Does it
X
matter
plus Y
which way
plus
you do
Z.
it?
Oh no, it doesn't matter. Yeah.
Marco, what does it mean by PQ is equal to XY? X plus Y plus Z equals 0.
Like
that?
it's like the difference of the two coordinates.
Ah.
Like you have to normalize them so that the sum is now 0. You have to normalize them to the same thing before you subtract. Does that make sense?
Oh, they're already normalized.
What?
They're already normalized, right?
Yeah.
What? How do we get the X, Y, and Z and that stuff for P and Q? Yeah.
Do we need to square root it at the end?
It shouldn't matter.
Oh no, we just compare the squared.
But Michael.
Huh?
How do we find P and Q again?
How do we what?
What?
Well, P and Q are P and C.
Yeah.
Oh, which one are you doing?
Oh, R and X. Like,
yeah.
how do we, what?
Just subtract them.
Oh, each one. Oh.
Yeah.
Okay. So that's X, Y, and Z, the subtracted things.
Yeah. Have you done Rx prime yet?
I'm doing. What do you want me to turn it into though?
No, leave it something. Oh, the P minus C should be pretty easy.
We've got it as something. Nice.
Did you get a factor of S minus C squared?
Not sure. S minus C squared.
Yeah. Hmm. Oh,
Oh yeah, I did. We got back to S minus C squared. Comes like S. What was your other factor other than S minus C squared? What other things did you get?
oh. I also I had like CS squared on the denominator. Yeah, it might not be important what the other one is. I think canceling out the S minus C squared will help. Because there's a factor of that on the PC as well.
Yeah.
Wait, what's the fact?
Huh?
What's the fact?
C minus S squared. Wait, did you get this? You got minus A squared B on S plus A minus C on S minus 1.
Yeah.
Right, which one are you doing, Lachlan?
The other one.
Or but is this for RX or PC?
And then for RX, it's so for RX, it's S minus C all squared, CS squared, A squared S minus B plus B squared, S minus A minus C squared.
So let's see.
Minus C squared. S minus A, S minus B. Is that what you got?
Yeah.
Yeah. So I think we can cancel. Like we can cancel the we can cancel one of the S minus C's.
Yeah.
Like we can cancel this.
Oh, shouldn't the last one be on C?
Which one?
The last one, the C squared.
On the left
Oh
or
wait, no, it should just be C, not C squared. Minus C, not minus C squared.
oh yeah, you're right. Yeah.
I just need to show you.
Yeah, so if we can cancel one of the S minus C's, right? With like the minus sign and one of these. And the S can cancel with the S. Yeah. Oops. I didn't cancel it here. But there's remember these things? They actually got S minus C's in them.
Yeah.
Remember that?
Yeah.
Like this is equal to S minus A times B plus C minus S. Remember that? Oh, sorry, it's the B plus A minus S. Yeah. Which is basically S minus C. Yeah? S minus C. This is S minus B, S minus C. Yeah? Remember that? So it was like S minus A times A plus B minus S. And this is S minus C. Okay. Oh, so that's already an S minus C. That can stay as a minus then. And that's an S minus C. Cancels with that S minus C. And we don't have an S to cancel. Oh wait, no, we had an SC on the bottom, didn't we? Yeah, an SC. Yeah, so the C squared, S squared. So the S cancels. So this is C squared. It's annoying. Yeah, so this is just a minus 1 on S. Yeah, that. Yeah. Okay. Yeah, I think we can cancel out another S minus C. Yeah, so cancel out another S minus C. So this S minus C with this S minus C. Yeah. And this S with this S. So we do it on each of these. So here, this S is gone. And then it's just on C. So this becomes B squared. Is this the S minus A1 or not? B squared. Is this the S minus A? B minus S. Yeah, the B minus S is the S minus A1. This is S minus A, S minus C, and that's the S minus C is gone, right? And then the S is gone. But it's still over C. Yeah?
Yeah.
The same thing here. This becomes over C. And it's an S minus B. Okay? Yeah. Okay, and then it's just a matter of comparing the rest of the terms. So if you oversee, it's A squared. Oh, we're missing an S. Okay, we seem to be missing an S here. We'll have an extra S here. And then this thing seems to be right. And this thing seems to be right as well. Yeah? We basically got everything except we seem to be missing an S here. What's happened? What's that one? That was PC, right?
Which one?
There seems to be an S missing here, that's it. Or an extra S here.
Where in the world did that one S come from? Shouldn't be there.
No, in which one?
For the RX.
The RX.
Oh.
Yeah, it doesn't make any sense. It's not there for B. The A and the B are symmetrical. They're not symmetrical, but they're like basically the same. It should not be a different term. The S you just messed up, and in mine I didn't get it.
I even asked him to check it.
Oh, sorry.
But there's just no S there.
Yeah.
Oh, it's like a squared on the bottom. I just left it as S on the bottom. Okay. But there is no S. So that's done then.
How to do this synthetically?
Well,
we do it one way. Don't you want to know how to do it the other way? Like you always.
I know, but not as the punchline to the other one. It's like, oh, now what do we have? We've done Bary. How do we do synthetic though?
Well, isn't that what you want to do? Once you've finished one, it's time for the next. I swear these are things you should agree with. Like,
I think timing matters.
Sure, but don't you agree that
I feel like you're not appreciating what we did for this one.
I do appreciate it. Very nice. Had a good batch.
Had a good batch. Yeah, that was pretty nice, right?
Yeah.
Like nothing too like overly complicated, yeah.
Yeah.
Everything kind
I was
of.
like, this felt pretty Bary.
I feel like the only thing though was we had to memorize the distance formula. That was a little bit like that feels
Yeah.
easy, but when push comes to shove, you might not actually do it. See, like,
Yeah.
will you actually take a week off before just memorizing the formulas?
No, that's boring.
See,
But that's also against what you would. You would not really support memorizing formulas for the
Since
sake
you want
of
us to prove it.
math. No, but not because you want us to prove it. But it's like it's against what you always preach.
I guess
What should
by the time it comes, hopefully, like we would just remember the formulas. Like, I mean, my memory's getting a bit worse, but I think at your stage, you probably can still just pull up the formulas, you know. And at worst case, you should be able to prove them. That's why we learn the proofs, just in case.
Should we prove it now?
Oh, do you want to prove it now? You can.
I want to do some polynomials.
I'll pull up the notes and we can go through the proof maybe next time, okay? So.